Hello guys and welcome back. Today we'll be continuing with our earlier series on getting the Arduino connected with Python and controlling the stepper motor using parameters defined in Python script. We'll be using some of the concepts we learned in our earlier series, such as transmitting data from Python to Arduino, parsing data once it's received, and using functions to control the speed, direction, and angle of the stepper motor. So let's get started. First of all, let me run through a little demonstration. Here we have the Python script, and let's run the script. A GUI should appear as illustrated in the middle of the screen, and we should have the Arduino output. Let me just activate the Arduino. Okay. Now if we run the GUI, let's set on the interface, GUI interface, we have the image of the stepper motor itself, the speed, the slider, which controls the speed in RPM, and the angle, which is measured in degrees. So let's set the speed to 8 RPM and angle, let's make it 90 degrees. If we rotate, if we press clockwise, the data is sent and the stepper motor rotates by 90 degrees. Let's have a look again here. And we can also run the stepper motor in anti-clockwise direction, as can be seen. We can reduce the speed to 5 RPM if you want to, and set the angle to 180 degrees, and let the stepper motor rotate in clockwise direction by 180 degrees. Same applies to anti-clockwise direction. On the right hand of the screen we have the outputs. So this is the first line indicate the data that's being transmitted from Arduino, from Python to Arduino. So we have the first set of data, which is 1, and then we have the separator A. Then we have the second set of data, which is the speed of the Arduino. And then we have separator B. Then we have the third set of data, which is the angle that we've set earlier. And then separator C, and anti-clockwise direction is being applied. Then separator D. Once we do the parsing, we can separate the sets of data to 1, 580, and anti-clockwise, and we use that data to control the motion of the stepper motor. Okay guys, so let's run through the script on Arduino IDE. First we are defining the global variables here, same as before, that are used in our program. We got the connection port, we've got the temporary variables that is used to control the script, as well as the variables to capture the parameters. So for example, we've got indices A to D here that separate the data sets, and in string format we have the variables used to control the motor, but these are converted into these variables, the one below, which are here, in order to capture the right data format which is used in our stepper motor. So in the void setup, we have our serial open, and the baud rate is set to 9600. All the connecting ports are set to output, and we're using the pin mode. And it's set to output because we're sending data through them to the motor. In our void loop, so initially we are waiting for the data from the serial, which is transmitted from Python. Once recognized that there is more than 0 characters, each of the characters from the string or from the serial is assigned to a variable called car data, which is char data, shown here. So we are checking if each of the variables whether equal to \n or not. \n usually indicates that we pressed enter. So if it doesn't equal to \n, we take the character in car data and assign it to indexed variable mod data, and we are using a variable called index_post to navigate through the characters. The navigation variable is increasing by 1 every loop. Otherwise, if the variable car data is equal to \n, we are making the last character \0, indicating that it's end of the string, and the navigation variable is 0 is assigned to the navigation variable. Once it's done, we run the function called parse the data, and we send a string value assigned to mod data. So let's lower our interface and see what's in the function parse the data. So the earlier mod_dir variable here, mod data variable, is sent to the function and assigned to data in, and the type is a string for the data in. Parsing of the data is same as before, where we capture the letters A, B, C, and D from our string, which separates the data sets. Then we extract the data between the separators, which is here. And assign them to a variable. And please note, some of the parameters are still in string format, hence require additional line to convert from string to appropriate format, depending on its purpose. Once the data is parsed and the parameters are assigned to global variables, we print them in our serial, allowing us to confirm if they are accurate. Then we convert the angle of the motor to number of corresponding steps, which is here, and convert the speed of the motor to the required time delay between the steps, which is here. This way we achieve the desired speed of the motor. If we find that the assigned direction in the motor_dir string, which is this variable, is equal to clockwise or anti-clockwise, we run an appropriate function here and add one more line towards the end to de-energize the last port that's been activated in the function. If otherwise, which is here, if the mod_dir string variable neither clockwise or anti-clockwise, we get a message in the serial saying that the data is invalid and to try again for the user. Let's go through the functions. So the functions to run the motor in a clockwise and the anti-clockwise direction has been discussed in our earlier session. Just a brief overview here. So here in this function, we energize the ports in a sequential manner, and we repeat this process until the number of steps correspond to the desired angle. So initially we have sequence number 1, where one of the ports is high and the remaining ports are low, and that energizes one of the coils in the stepper motor. Then in the second sequence, we have the second port high and the remaining is low. That energizes the second coil in the stepper motor, and this sequence repeats a number of times. So between the sequences, we are pausing for certain interval to achieve the desired speed for the motor. The process in clockwise is the same as in anti-clockwise. Just the sequence is reversed here. Okay, once we finish setting up our Arduino IDE, let's jump to Python script. So let me just disable this and enable the Python. In Python, there are two main actions happening here, which are creating functional GUI and sending data to the serial port. So here above, we are starting off by importing PySerial module, time and TKA inter libraries, and defining the variables that will be used in our script, which are here. Then we are defining the serial port, starting from here all the way to there, and opening it up before sending any data. Before going through the functions, let's run through the main script first, which is down here. Here we are defining the parameters of the GUI interface and assigning functions to the widgets that we assigned in the GUI. First, we create the image for the GUI as it will be positioned at the top of the interface. Then we're creating a label and a slider widget that will be used to adjust the speed of the motor. The speed is measured in revolutions per minute, and the slider increments from 1 to 9 and expands across the width of the interface. As we move forward, we create a label and an entry box that is used to set the rotating angle of the motor. The angle is measured in degrees. And for the final step, we have two widgets, which is clockwise and anti-clockwise buttons. So the widgets are here. These buttons set the direction and transmit the data to the serial using a command method. It assigns a functions to the button. Let's move up the screen to access the functions. So it's here. Rotate clockwise and anti-clockwise. The directions are assigned to a variable called moddir. So direction either clockwise or anti-clockwise, which is used as an input function as an input variable to a function send data. Okay, so as for the send data function, let's move up to line 29. That's where the function starts. We are starting off with a variable mod run, and a constant value of 1 is assigned. So we're not changing much this variable at this point, but it could be used later on if we want to indicate if the power is on or off or any other kind of navigation inputs. Then we have a variable modSpeed int, which is retrieved from the slider using method get, and it retrieves integer value, which is then converted to string value in line 34. And as for the motor angle, which is here on this on this line, we are also using a get function, method from the entry box. Based on this data, we are using if statement to check if the input data either empty or not empty. So if it's not empty, then we encode the data and send it to the serial. If not, if it's empty, then we display a message in one of the label areas saying please input angle. The message is displayed for 1 second. And for the final part, we have mod_dir variable, which is determined in the earlier steps and sent here as an input. So all the data here is being encoded to UTF-8 and being sent to the serial with the corresponding separators. As we define all the functions, all the variables, we run this function confirm transfer. What this does is displays a message saying data has been sent on the image that we've inserted earlier. Okay, so let's try to run this again. Let me bring this slightly down and activate the GUI, as well as have the Arduino output displayed. This enables us to see what are the data that's coming in. Okay, if I set the speed to 9 RPM and angle 90, so we can run the stepper motor clockwise. We can also run anti-clockwise. You can see here. We can change the speed of the motor to 5, let's say, and angle, let's set it 360, 1 revolution, and let it rotate clockwise. On the right hand of the screen, we can see the data is coming into our Arduino and it's being parsed one by one. Let's run the stepper motor in anti-clockwise direction. Same as before, it runs okay. Great. I think we'll just wrap this up here. It was a very interesting project to work on. I hope you guys enjoyed. Make sure to like this video and subscribe for further series. Thank you for watching and see you later.